All right, we had one question left that we were taking a look at in 7.2, and it will be necessary for you to grab your calculator to take a look at this particular problem. So if you go ahead and grab that out. And I'll remind you what we spoke about last time about this very interesting sort of example. A student is trying to calculate a number that is approximately 1 to the 10,000 power. And she's getting an answer that's extraordinarily close to 0, not close to 1. And she's wanting to know why that's happening, okay? Because it seems a little odd, right? It seems like it should still be close to 1 if she's multiplying a number that's really close to 1 by itself a whole bunch of times. So, all right, there it is. What I'd like for you to consider is what happens when we multiply the 0.999 number just twice, like multiply it by itself twice. So take the number 0.999 and square it. Okay? Just squaring, nothing, I mean, we're not raising to the 10,000, we're just squaring. And what number do you get when you square this value? Okay, is that what everybody has? Awesome. So the first thing I'd like for you to recognize is that it got smaller, right? I mean, not a lot smaller, but it was smaller than it began when it was just multiplied by nothing, right? So what we're going to do is we're going to kind of repeat this process several times and just see what happens as we take these values and they get multiplied more and more times together. So we're going to take this same thing, and so what we're going to do is to simply square it again. So what you already have in your screen, just hit squared, and it will automatically take your previous answer and square it. So we're taking the 0.998001, and we're raising it to the power 2. Like we're squaring it. And when we do that, what do we get on this time? I'm going with 6 on my paper, so we'll stick with 6. 6006. Is that what it looks like, Brooke?
Yeah, if you round it.
Yeah, round that last one. Okay. Just as a sort of word of advice, we're squaring every time, but just so that we can see what's happening here. In fact, I'll move it over. We're raising these to powers of this one would be the power of 4 since we squared it, right? Squared it twice, and we got this number. So let's go with that. Clean up what I'm writing down so it has a little bit better. And we're going to keep squaring it. So we're going to square it again. So if I squared it again, that would be basically raising it, not basically, exactly, raising it to the power of 8 because I'm squaring the 4, so 2 times 4 would be 8. What happens when I multiply this again? I've got 028, yeah, for 6 decimals. So again, it's getting smaller, but I mean, let's be honest, it's still super close to 1. I mean, this is still about $1 if you had to pay the money for it, right? Yeah, it is. Let's keep squaring. We're going to square a few more times. So if I square it again, I'm raising it to the power 16, right? So if we square it again, what do we get? Yeah, 4119. That's the most significant change so far. I don't have 99 cents, quote unquote, anymore. It's 98. Let's try it again. So if I square it again, that's the same as raising it to the power of 32. What happens? Okay, so this is finally not as close to 1 as we might look at that and just say, oh, it's about 1, right? You get to 0.96 and you're not thinking, oh, it's about 1 anymore. And we're only at the power 32. So we're going to do it a few more times. If I do it squared again, squaring it again raises it to the power of 64. What happens with that value? Yep. Okay, we're still not close to 0. I recognize that. But can you see that we're moving away and more quickly as we keep squaring, right? The further we square, the more quickly we are moving away from the number 1. Let's square it again. That's essentially power 128 when I square the 64. Ooh. Yep. Yikes, not even in the 90s anymore. So we're going to square it again. So squaring again gets me at the power 256. Ooh, and all of a sudden we're actually, yeah, we're in the sevens, the 70% sort of range, right? We're at 774043. We're going to do this a couple more times here, okay? 999, square it again. This puts me at 512, I think. Yep, 512. Yeah. Where am I now? I mean, I skipped the 60s altogether, didn't I? 5989, I'm sorry, 59142. 599142. There we go. Okay, we're one more time. This is our last time that we're going to raise this to a power. So if I double that again on the exponent, I have 1024. And where am I? Okay, so I'm only at an exponent of about 1,000, and I'm gearing towards being at an exponent of about 10,000, and you can see how quickly things are starting to deteriorate, right? And that's because, I mean, it seems like, oh, we're just squaring every time. We're really squaring by something that's significantly smaller than we multiplied by before, right? So that's why it's happening. But yeah, the numbers are definitely getting smaller. So what's really going on here? Well, it's something like this. So what happens when you multiply by a number that's between 0 and 1? So sort of a less than 1 positive number. What happens? Do the values get bigger or do the values get smaller when you multiply? They get smaller. So anytime you're multiplying by a positive number that's less than 1, right? Think 1/2, if it helps you to think about that. When I multiply by 1/2, the value I get is smaller than it was before. All right, and that happens no matter how close to 1 we are. This one was awfully close. It was 999 thousandths. That's what it was. Like 999 over 1,000. That's how close we were to the number 1. And it still will get smaller because the number's less than 1. So whenever you multiply by a number less than 1, and I'm going to put positive here. We're talking about positive numbers. Your product let me say will be, actually. Your product will be smaller than your factors. Factors are what you're multiplying. The product is the result of the multiplication. They'll be smaller than your factors. in this problem, we are doing this. That is, this multiplying by a number less than 1. $10,000 times. Sorry, I ended up writing a little smaller than I was expecting, so I'm just large a little bit. Yeah, so we only did it 1,000 times. That's how far we went down the bunny trail, so to speak, and we're at about 35%, right, of where we started. 36% of where we started, and we only did it 1,000 times. So if we did it 10,000 times, you can see why it becomes really, really small, because every single time we do it, it gets smaller. Okay? Cool.